Everything we've built so far has one blind spot. It only understands text. But real documents are full of things that aren't text. Photos, charts, diagrams, scanned tables, screenshots. Standard RAG either ignores these completely or runs them through OCR and captioning, a lossy process that flattens a rich chart into a few words and throws the rest away. Multimodal RAG fixes this by changing the pipeline in three specific places: how we embed, how we retrieve, and how we generate. Let's compare the two pipelines side by side and then dig into each upgrade. On the left, standard text RAG. On the right, multimodal RAG. The skeleton is identical: embed, store, retrieve, generate. The first difference is the embedding space. Text RAG embeds only text. Multimodal RAG embeds images and text into one shared space, using models like CLIP. The second is retrieval. Text RAG matches text against text. Multimodal RAG can match a text query directly against images and even against whole document pages, with techniques like ColPali. The third is generation. Text RAG feeds text to the model. Multimodal RAG feeds the actual images to a vision language model that can see them. Three upgrades: shared embeddings, cross-modal retrieval, and multimodal generation. Let's take them one at a time. Start with the embedding space. The classic tool is CLIP, trained by OpenAI on hundreds of millions of image and caption pairs. CLIP has two encoders, one for images and one for text, and the whole trick is that both project into the very same vector space. During training, it pulls each image and its true caption together and pushes mismatched pairs apart. So a photo of a dog and the words "a dog" end up as neighbors. Now your text query and your images live in one space, and the same Cosine search from before retrieves images directly. That is cross-modal retrieval. But CLIP has a limit. It squeezes a whole image into a single vector. That's perfect for a photo, but for a dense document page packed with text and tables, one vector simply isn't enough. Which brings us to documents and to ColPali, a 2024 method that rethinks retrieval for visually rich pages. The old way to handle a PDF page: OCR it into text, detect the layout, chunk it, caption the figures, a long, brittle pipeline that still loses the visual structure. ColPali's idea is radical. Don't pass the page at all. Take a screenshot of it and embed that image directly with a vision language model called PaliGemma. And unlike CLIP, it does not produce one vector. It splits the page into a grid of about 1,000 patches and embeds each one, so a single page becomes many vectors. To score a query, it uses late interaction. For every word in your question, it finds the single best matching patch on the page, then sums those scores, the same Maxim trick from Colbert, now applied over pixels. The payoff is huge. The entire OCR and parsing pipeline collapses into screenshot, then embed, and layout, tables and figures are finally captured natively. Retrieval has found the right images or the right pages. Now we have to generate the answer. In text RAG, we stuffed text chunks into the prompt, and the model only ever saw words. Multimodal prompting changes the model itself. We hand the retrieved images directly to a vision language model like GPT-4o, Claude, or Gemini. Now the model doesn't read a caption of the chart. It sees the chart, reads the table, and reasons over the pixels themselves. Ask it which quarter had the highest revenue, and it can answer by actually looking at the bars and cite the exact page it saw them on. Put it together, and the multimodal pipeline looks like this: embed text and images into a shared or multi-vector space, retrieve across modalities, and generate with a model that can actually see. So when do you use what? For searching natural images, product photos, or media libraries, CLIP-style shared embeddings are perfect. For visually rich documents, PDFs, slides, scanned reports, ColPali lets you skip the brittle parsing pipeline entirely. And whenever the answer lives in the pixels, a chart, a diagram, a form, multimodal prompting lets the model actually look. Multimodal RAG in one line, retrieval that finally stops throwing away everything that isn't text.